Hello students, welcome back to this lecture. In this lecture, we will see what is the difference between a nominal mix and also what do you mean by a design mix. So before we understand that, in the previous lecture, I told you that there are different grades of concrete, right? And I also told you that M20 is a minimum grade of a concrete that we are supposed to use. So we'll try to see where exactly it is written in the Indian Standard Codebook, and we'll try to understand that. So if I go to this codebook of Indian Standard, and I'll show you here where it is exactly written. Yeah. So if you go to the table number 5, it's written page 20 and it is IS 456-2000. So it is written here. One is plain concrete, which is usually plain PCC, what we call plain cement concrete. The other one, what we have is a RCC, which is called as reinforced concrete. Now here you can see something written. It is an exposure condition, whether it is a mild exposure, moderate exposure, severe, very severe, or extreme conditions. So we'll try to understand what exactly is severe, what exactly these conditions are. But now you see here under the mild condition, if I go to the reinforced concrete and if I check here, if I go to the mild and under the mild, if I go to the minimum grade of concrete, so this is my minimum grade. So this is my minimum grade, right? So what you can see here, M20 is written. So this M20, what it is written for the mild exposure. So according to IS 456, M20 is a minimum grade of concrete that we are supposed to use in the RCC structure. That's the first thing we understood from here, right? And also it will indicate us, suppose if you're preparing a mild exposure and if you're preparing a M20 grade of concrete, what has to be the minimum cement content? So it has to be minimum 300 kg per cubic meter and maximum water cement ratio, what you can maintain is 0.55. Suppose if you're using M25 grade of concrete, the minimum cement content should be 300 kg per cubic meter and the maximum water cement ratio, what you can allow is 0.5. We'll try to see what exactly this water cement ratio and all, how it's going to help us. But try to understand all these things will be given in this particular table, right? So this thing is clear. Now we'll go back to this about the exposure condition. Yeah. Now coming to the exposure condition, what exactly this exposure condition are? Let me put it in a very simple way. Let us say I'm constructing a house which is somewhere close to the coastal region. Since my house is very close to the coastal region, it is most of the time subjected to the sea waves and the temperature will be very hot there, right? So that exposure is that is my building, what will happen, it is subjected to this sea waves. So the exposure condition is different there, right? Now let us consider I'm constructing a house somewhere where out of 1 year, that is out of 12 months, let us say 7 to 8 months is going to rain and it is going to rain heavily. So in that case, what will happen? 8 months, my entire building will be subjected to the rain. That means there is a frequent wetting of my building. Again, that exposure condition is different, right? Now let us consider I'm constructing a bridge and if there is a pier, right? Pier in the sense the middle part is called as pier, the ends are called as abutments. Now, since you're constructing a pier, it is in contact with the water. If I have a pier here, it's contact in the water. So throughout the lifetime of this particular bridge, this particular pier is going to be in contact with the water. So that means the exposure condition is different because all the time it is contact with water. So it's a different exposure condition. Now, based on the exposure condition, we are going to decide whether it is mild, moderate, severe, very severe, or extreme condition, right? Now, if you're putting up a nuclear power plant, or if you're putting an underground water tank, in that case, again, that water tank is constantly in contact with the water, there the exposure condition is different, right? I hope you got an idea what exactly this exposure condition is. Now to speak in terms of technical, they have written it here, environment, you can see it here, environmental exposure condition, and it is clause 8.2.2.1 and 35.3.2. So it is written mild, moderate, severe, very severe, and extreme condition. So what are these exposure conditions? If you're going for a severe, in that case, your concrete surfaces exposed to the severe rain, alternate wetting and drying, or occasional freezing, or severe condensation, and concrete completely immersed in the seawater, and concrete exposed to the coastal environment, right? In that case, your condition is a severe condition. And if this is a severe condition you're building, then you have to come here and under the severe condition, what your code says, what should be the minimum grade under the severe condition. So this is my severe condition. And under the severe condition, what is the minimum grade of concrete I'm supposed to use? I'm supposed to use M30 grade of concrete. So I'm going to say, I'm going to use M30 grade of concrete, right? From here, we are going to identify what grade of concrete we are supposed to use. But usually most of the construction in a normal area and all, if you're constructing a small house and all, mild and moderate condition is that which usually prevails, like M20 and M25 grade of concrete. But again, the code says that if you're putting up your structure in the coastal region, you can see it here. Just observe in this part. Yeah, concrete in seawater. Concrete in seawater or exposed directly along the sea coast shall be at least M20 grade in case of PCC, that is plain concrete, and M30 in case of reinforced concrete. That means if you're putting up a RCC structure near the coastal region, the code says that you have to use M30 grade of concrete if it is a coastal region. Otherwise, all the normal building has to be M20. Again, the code says all these things. So based on it, we are going to decide which grade we are supposed to use, right? I hope these concepts are clear for you. Now, one thing might have come in your mind that I told for M7.5, M10, M15, M20, M25, we have those ratios like proportions, 1 is to 1.5 is to 3 or 1 is to 2 is to 4. But if I say M30 grade of concrete, if I say M30 grade of concrete you have to put, then where is the ratio? We don't have any ratio, right? So now that is where the concept of nominal mixed design and mixed design comes into play, and we'll try to see that. So I'll take you to that particular slide now. First, we'll try to understand what is nominal mix, and then we'll try to understand what is design mix. Yeah. So coming to the nominal mix, these are those mixes whose proportion of ingredients are fixed, like 7.5, 10, 15, 20 we had, right? For M15, it is 1 is to 2 is to 4. For M20, it is 1 is to 1.5 is to 3. For M25 is to 1 is to 1 is to 2. So this is fixed. No one can change it. Now, for example, right now I'm in Karnataka, a place in India, right? So if someone tells me prepare a M20 grade of concrete, I won't ask you any questions. The moment you say me M20 grade of concrete, I know the ratio. It has to be how much? I'll write it here. Someone told me prepare a M20 grade of concrete. So the moment he says M20, I know that I have to add 1 part of cement. I have to add a 1.5 part of sand, and I have to add 3 parts of coarse aggregate. Done. Now, let us say one of my friend, he's in Delhi. I'll write it here. Right? Delhi is the capital of India. So if somebody says him prepare M20 grade of concrete, again, he is not going to ask you any question. So directly, even he also knows that it has to be 1 is to 1.5 is to 3. Good. So this is constant throughout the country. Now, when we go for the mixed design, it is completely different, and we'll try to understand that. I hope this concept is clear about nominal mix. When I say M20 or M15 or M10, it is same throughout the country. There is no change in that fixed ratio. Yeah. So the ingredients are mixed based on the volumetric basic. That means when I say 1 is to 1.5 is to 3, how do I measure that? This is that measuring volume what we have. Suppose if I say 1 is to 2 is to 4, how do you prepare that? In that case, what you're supposed to do, you have to fill this entire container with cement 1 time, that is called as 1. 2 in the sense it is for sand, so you have to fill this entire cylinder, entire container 2 times with the sand. 1 time you'll fill and you'll put it again, you're going to put again you're going to fill and you're going to put, and when I say 4, you have to fill this particular container 4 times. Only then this will become my 1 is to 2 is to 4 ratio. But here what is happening, based on the volume you're doing, not on the weight. It's not like I'm not telling you take 50 kg of sand, take 100 kg of coarse aggregate. I'm not speaking in terms of weight. I'm speaking in terms of volume. So this is the volume. So that is why most of the nominal mixes, they are we use nominal mixes in terms of volume batching. Okay, that is the first thing you need to understand. Now we'll come to the design mix. So what is this design mix? These are those mixes whose proportions of ingredients are not fixed. That means for M30, we don't have ratios. For M35, we don't have ratios. So these are called as design mixes. So in this, what we do, we will take individual materials. Like if I want to prepare M30 grade of concrete, I'll take a cement, I'll take sand, I'll take coarse aggregate, right? And I'm going to individually do the testing on that. I'm going to do the specific gravity test on that. I'm going to check the I'm going to do the sieve analysis for that. And then there's a code book called IS 10262 2019 code book. I'll show you that. So this is that code book. Yeah, you can see it here. No, it's written IS 10262. Okay, from this code book, you have to do all these manual calculations, like See, I won't explain all these things here. It is already explained in my concrete technology course, but I'll give you idea. So all these formulas you need to apply. That is F dash CK is equal to FCK plus 1.65. Like that means if I want to prepare M30 grade of concrete, then I have to put 30 plus 1.65 into S I need to do, and all these manual calculations I need to do. Okay. Once I do all these manual calculations, finally I'll get that my cement will be 350 kg per cubic meter. Water will be 140 kg per cubic meter. Fine aggregate will be 896 kg per cubic meter. Coarse aggregate will be 1140 kg per cubic meter. Forget about the chemical admixtures, and water cement ratio will be 0.4. So from this, I'm going to get that ratio for M30. How do you get the ratio? It's very simple. Write down the answer directly here. Say I got 350 here. I got 350 for cement. For fine aggregate, it is 896, right? And for coarse aggregate, it is 1140. So for ratio, what you have to do? 350 by 350, because for ratio, I'll divide it by cement quantity. So 350 by 350 will come out to be 1. Okay. And now 896 divided by 350. 350. And for coarse aggregate 1140, you divide it by 350. Now, if I do it manually, let me do it. Yeah. So 896 divided by 350 will be 2.56. I'll write it here. Text. So my ratio will be 1 always for the cement. It is 2.56 is 2. And for aggregate, it will be 1140 divided by 350. So it is 3.25. So this is my ratio for this particular M30 grade of concrete or whatever it may be. Now another question will come in mind, whether this ratio is constant, that if I say M30, then you will take 1 is to 2.56 is to 3.25. This is not constant. Why? Because right now, let us say this particular ratio, what I've got, no, like 1 is to 2.56 is to 3.25. This is the place where I'm staying. Right now I'm staying in Bangalore. So this is a ratio what I got based on the quality of the cement I'm getting, based on the quality of the fine aggregate I'm getting, based on the quality of the coarse aggregate I'm getting, and based on the quality of the water, I got this answer, right? So that is why if you go back here in the question, all these things will be written here. What is a, you can see it here, no? What is the grade you're putting up? It's a M40 grade of concrete. What is a grade of the cement? Here they have taken 43 grade. If they had taken 53 grade, they would have got a different answer. What is a nominal size of aggregate you have taken? It's a 20 mm size. What is the maximum water cement ratio you have taken? 0.45. What is the slump that you wanted? And what is the specific gravity of the cement? What is the specific gravity of the coarse aggregate? What is the specific gravity of the fine aggregate? Right? All these things you need to understand. Of course, it's a completely a different chapter. Concrete mixed design is not that easy, like I'm explaining. You have to do trial and error, and finally you have to get a value, whether it is satisfying the criteria or not. But I'm giving an idea how we are getting that ratio, right? So in Bangalore, I'm now whatever sand I'm getting in Bangalore, suppose whatever answer I got, right? If I go back, see, this is a ratio what I got. 1 is to 2.56 is to 3.25. This is what I'm getting in Bangalore. Now let us say I'm going to Kolkata, and if I ask you to prepare the same M30 grade of concrete with the help of mixed design, you're not going to get the same ratio. Why? Because the sand, the quality of the sand what I'm getting in Bangalore may not be the same quality of the sand what I'm getting in Kolkata. The quality of the coarse aggregate what I'm getting in Bangalore may not be the same quality of the coarse aggregate what I will be getting in Kolkata. The quality of water what I'm getting in Bangalore may not be the same what you're going to get in Kolkata. So from place to place, there's a variation, and also the quality of the cement. And if there is a variation, obviously this ratio is not going to remain same. So it may change. It may come out like 1 is to, let us say 2.4 is to, let us say 3.6. So that is a variation you're going to get. So always remember, mixed design, you're not going to get same answer. Whereas in nominal mix, you're going to get, like if I go back. Yeah. So that is why you can see it here. The ratio of proportion varies from place to place depending upon the quality of the materials, grade, and company of the cement available. Here, the tests are conducted on each and every ingredients, and only after that the ingredients are used. Like you're going to check the specific gravity of cement, for fine aggregate, for the coarse aggregate. Even for the water, you are going to do the quality testing. Because we want the pH of the water in between 7 to 7.5, right? Again, that is mentioned in the code book, like what should be the pH. Also, you have to check the organic matter, what is present. Let me give you a small idea. If I go back to the code book again, yeah, yeah, you can see it here, what is written in the code book. The pH of a water shall not be less than 6. It is written in the code book that pH of the value should not be less than 6. Other than that, these are the permissible limit for the solids. Okay, in the water, all these limits, what you can see, organic, inorganic, sulfates, chlorides, all these things should be within this permissible limits of 200 milligram per liter, 3000 milligram. So all these things you don't have to. They are called as we have third-party consultants. If you give the water to them, they are going to do all the testing, and finally they are going to tell you that this particular water is good. So you can see it here. Water found satisfactory for mixing is also suitable for curing of concrete, right? So water which we drink, no, that is good for making the concrete. So all these things you need to consider, and only then you can prepare a mixed design. So that is why you don't get a what you call constant answer for the mixed design. It will vary from place to place, right? So I hope you have got an idea, at least a basic idea, how exactly all these things are prepared. Yeah. So again, the grade of a concrete from M25, M30, 40 and above, all are this mixed design. Okay. Even M20 also you can do mixed design, but usually we don't do, because whatever we are getting, like 1 is to 1.5 is to 3 for M20, that is good enough, and it's going to give you a good strength. But above M25, like even M25, we don't go with a nominal mix, even though we have this 1 is to 1 is to 2, we don't do that. For M25, we usually go with the mixed design. We are going to do the manual calculation, and we are going to do the mixed design. For high-rise structure, it is always mandatory to use the mixed design. When you're putting up a structure like G plus 10, G plus 11, 12-story building, 13, 14, 15, whatever it may be, always it is recommended to make use of mixed design. The ingredients are weighed here, and the concrete is designed using IS 10262 code book. That means, again, one more thing, what is the difference between a nominal mix and the design mix is, in nominal mix, it is mostly based on the volumetric basic. That is, we have seen that container, right? With the help of the container, we try to measure the quantity of the cement, fine aggregate and coarse aggregate. Here you are not going to make use of that particular container. Here what will happen, based on the weight, if I say 50 kg, 50 kg of cement I'm going to take. If I say 200 kg of fine aggregate, I'm going to make use of 200 kg of fine aggregate. If I say 500 kg of coarse aggregate, I'm going to take 500 kg of coarse aggregate, right? So here there won't be any changes, but in nominal mixed design, there is a changes. So that is why when you go for the, anyhow, I'll show you a practical video of how this mixed design is actually prepared. You can see this is how that batching plant is kept ready. So here you have different ingredients, like you have fine aggregate and you have coarse aggregate, and through the conveyor belt they are going to come. The cement is stored here. These are called as silos, and through this, with the help of the weight, there is one person sitting inside. He'll operate all these things. This, yeah, you can see a small cabin here, right? Through this, he's going to do the operation, like how much cement should come, how much fine aggregate should come, how much coarse aggregate should come, how much water should come. Based on that, based on the way batching, all these mixed designs are prepared. Okay. In a volumetric batching, that is in a nominal mix, we don't have such system. Directly on the site, with the help of labors, we do that. But if it is a design mix, we have to do something like this. Anyhow, we'll see the practical video of this, how exactly all these things are done. Yeah. Now, yeah. So now I put it in terms of chart, like one is nominal mix, other is a design mix. We'll quickly try to understand this. So coming to the nominal mix, the ratio of ingredients are fixed, like cement, fine aggregate and coarse aggregate and plus water, everything is fixed here. The ratio of ingredients are not fixed, but they are got with the help of a mixed design using the codebook IS 10262 2019 is a new codebook what we have. The mix is obtained by volumetric batching, but here the mix is obtained by wave batching. Here, no quality control is followed here, and no individual testing of materials is done here. That is, in volumetric batching, usually there is no quality testing. Whatever aggregate you are getting, whatever fine aggregate you're getting, directly are making use of it. We are not going to do the testing of even the water there. But in case of design mix, usually we will do the uh, uh, testing of the fine aggregate, coarse aggregate. We are going to do the testing on the water as well. Next, no slum test and cube testing is done here. We'll try to understand what is this slum test and cube test in the upcoming lectures. But here we are going to do the slum test and cube testing so that we can get an idea whatever grade we are prepared, whether the same grade is achieved in the concrete structure or not. So that is the importance of doing the cube test here. Next is, here it is assumed that the required strength is obtained. When we do the nominal mix design, we achieve that whatever mix we are preparing, no, that much amount of strength is we are going to achieve. We are not going to verify that. But here, what will happen? We are going to justify that whatever concrete we have prepared and whatever concrete we have put it in the structure, the same strength is achieved with the help of a cube test. And we are going to do the proper lab testing of this cube. We are going to prepare the cube. We are going to put the compressive strength on that. And after the 28 days, we are going to check whether M30 grade of concrete, what we prepared, exactly is getting a strength greater than 30 Newton per mm square or not. All those things we do in the mix design. Next is, materials used here is cement plus fine aggregate plus coarse aggregate and water. These are the usual material that you are going to use. But when it comes to the mixed design, you are going to make use of cement, fine aggregate, coarse aggregate. Along with that, of course, the water. We make use of certain plasticizers, and also we make use of certain pozzolaners like fly ash and GGBS, right? Next, use for the concrete of grade up to M20 and less. Like if you want to prepare a grade of M20 or even less than that, like M15 and all, then usually we go with a nominal mix. But here you can make use of this for any grade, but usually for M25 and above that, we are going to make use of this mixed design, right? So this is a basic difference between the nominal mix and the design mix. Now to put everything in a very crude way, it's very simple. Now you go to any market, okay, what is I'll put it in one line, the difference between a nominal mix and the design mix. Okay, in nominal mix, what will happen? There is no bargaining. You go to any shop, you can see they are going to put certain sale, right? Sale 50 rupees, and this is a fixed rate, no bargaining, right? Sale 100 rupees, no bargaining. In a mix, in the nominal mix, what will happen? If I say M20 grade of concrete, the ratio is 1:2 is 1:1.5:3. If it is M20, if it is M15, it is 1:2:4. There is no changes in that. Throughout the world, this ratio remains the same. So it's same throughout this shop. You go, you look into any cloth, the rate is fixed. You cannot bargain here. But if it is a mixed design, what will happen here? Based on your bargaining skills, based on your experience, you can bring down the rate of this particular cloth to the lower price. Let us say you went and asked for this particular top, and the shopkeeper told it is like 200 rupees. Now you know that by now you took that particular cloth, and just by looking at the cloth, you came to a conclusion this cloth is not worth for 200. You can bring down the rate by bargaining, and let us say you got it for 150. How did you get it for 150? Based on your bargaining skills, based on experience, you got it. In the same way, when we go for the mixed design, what we do the individual testing on the materials like cement, fine aggregate, and sand and water. And through my experience, through the mixed design, I'll do the calculation, and finally I'll prepare a very good mix for that, right? So that will come through experience, and that is how the difference between the nominal mix and the design mix is all about. So I hope yeah. So I hope you understood the concept up to here. We'll see you back in the next lecture. Thank you.